Welcome to today's episode. We're diving into the fascinating world of robotics and reinforcement learning, specifically focusing on unitary robots and how they can be integrated with cutting-edge technologies. So if you've ever wondered how robots learn to walk or perform tasks, you're in the right place. Today we're going to break down the process of setting up and training unitary robots using the Unitree RL Gym, a powerful framework for reinforcement learning. To kick things off, let's talk about what unitary robots are. Imagine having a robot that can navigate complex environments, adapt to changes, and learn from its mistakes. That's what these robots do. With models like the Go2, H1, and G1, they are designed for a variety of applications, from agile navigation to complex robotic tasks. Now, you might be thinking, sounds interesting, but how do we actually get started? Well, let's get into the nuts and bolts of installation and configuration. First off, you need to create a Python virtual environment using Python 3.8. It's essential for managing dependencies and keeping your projects tidy. Next up, you'll install PyTorch with specific commands to ensure you have the right version and CUDA setup for compatibility. For instance, with just a single command, you can install PyTorch 2.3.1. But that's just the beginning. Once that's done, you'll want to download the latest version of Isaac Gym, which is vital for simulating robotic interactions. Now, I know what you might be thinking. Isaac Gym? What's that? Well, think of it as a virtual playground where your robot can learn through trial and error, all while you sip your coffee. But before you jump into training, let's pause for a moment. Have you ever played a video game where your character learns from mistakes to become stronger? That's very similar to how reinforcement learning works. It's all about learning from feedback. This brings us to the training phase. Once your setup is complete, you can run a training script. Just imagine programming your robot to ace a specific task, like navigating a tricky obstacle course. Isn't that cool? And the best part? You can run the training on a CPU or even a headless setup without the need for rendering graphics, all to optimize performance. But what happens after the training? Well, the trained policy, which is basically the knowledge your robot has acquired, is stored for you to use later. How wild is that? And guess what? You can even resume training if you want to improve or alter the robot's capabilities. Now, if you're itching to see this in action, you can also run a play demo with your trained robot, and it's as exciting as it sounds. It's like watching your digital pet perform tricks that you've taught it through rigorous training. And if you're feeling adventurous, you can even simulate interactions in Mujoko. It acts as another layer of simulation for testing and refining your robotic algorithms. Think of it as a next-level simulator. Before we wrap up, here's something to ponder. What would you train your robot to do? Rescue missions? Racing to finish a course? The possibilities are endless. Today, we've unpacked a lot about unitary robots and reinforcement learning, from setup to training and even real-world deployment. It's an exciting time in technology, and who knows what the future holds for robotics. Thank you for tuning in today. If you enjoyed this episode or have further questions about robotics or AI, don't hesitate to reach out. Until next time, keep wondering and exploring the incredible world of technology.